Okay, number 10 says to completely analyze a function. And that means to find the critical points, the points of relative extrema, the concavity, and the inflection points. And number 10, I've kind of broken up into like little chunks. So the first chunk is to find the critical points. Ooh, I totally burped, I'm sorry. But to do that, I would first start by taking the derivative. Okay, so if I bring down the 3's will cancel, and I get 2x squared. And then bringing down the 2 again, the 2's would cancel, I just get an x. And then minus 6, derivative of 15 is 0. So this is a quadratic, so it's going to look something like that or something like that. So it's definitely continuous everywhere. So there's no places where the derivative is not defined. So I'm just going to set it equal to 0 and solve. And to solve a quadratic like this, there's a couple of different options. One of them is the quadratic formula. Another one is factoring, and let's see. Oh, just using a square root can sometimes work. But in this case, I think I'm going to try to factor. So there's a 2 up front, so I'm just going to assume it's going to be something like 2x here and a 2x there. Not a 2x there, because that would give me a 4x squared. Just a regular x. And then I need something that multiplies to be negative 6. So my guess, I'm going to try a 3 here and a 2 there. If you're new to factoring, this is something I am kind of assuming you're familiar with. So if you're not familiar with it, post a question on the discussion board and I can get you material. But the last thing I'm going to do is I need to figure out if there should be a plus here and a minus here or the other way. And I might be wrong with the 3 and the 2, but we'll find out. I'll start by trying to multiply it out. So 2x times 2x is 2x squared. Then plus 3x minus 4x minus 6. Okay, 3x minus 4x gives me a negative x, and what I wanted was a positive. So I'm going to try opposite signs. See if that gets me the right thing. I'm pretty confident that it will, but I always feel like it's a good idea to multiply it out and check. So a minus there and a plus there. So 2x times x is 2x squared. And then 2x times 2x, that's a plus 4x. Then minus 3x, and that is looking much better. Okay, perfect. So now, since I have two things multiplying together to equal 0, I can solve each one independently. So I'll solve 2x minus 3 equals 0. So that'd be 2x equals 3, or x equals 3 halves. So that's one solution. And then the other solution, x plus 2 equals 0, just gives me x equals negative 2. So I've got my critical points. Now I will find my possible inflection points, which is where I take the second derivative. So second derivative, using this equation that's up here, right there. So I bring down the 2, that gives me 4x. And then derivative of x is just 1. Derivative of a constant is 0. This is a straight line that's defined everywhere, so there's no places where the second derivative is undefined. So I'll just set it equal to 0 and solve. So if I subtract 1, I get 4x equals negative 1, or x equals negative 1/4. Okay, so then the second idea, not the second idea, the third, I can count 1, 2, 3. The third thing down says to do the second derivative test for the min or max. So these values up here are critical points where the slope is 0. So it's possible that those are mins and max, relative mins and maxes. It's the question of the day. So to test that, I'll test the concavity at that point by plugging them into the second derivative. So let's give that a shot. I need the second derivative of 3 halves. and the second derivative of -2. So plugging that into this equation, I get 4 times 3/2 plus 1. Whatever that is, that's definitely greater than 0, so it's a positive thing. And -2, if I plug that in, 4 times -2 plus 1. -8 plus 1 is -7. That one is less than 0. So this is the part where we have to think about what this means. At 3/2, when we plugged in 3/2, we get something that's positive, which means it's concave up there. So that tells me that that's a relative minimum. So let's get rid of that and put relative minimum. Relative minimum. Now the opposite is true over here. When I plugged in -2, I got a negative number, which means that it's pointing down. It's concave down, which corresponds to a max, a relative max. Oops, relative, my bad. Relative max. All right, the next question we want to figure out is where is it increasing or decreasing? And so I'll plot in my points here at x equals 3/2, which is 1 1/2, and x equals -2, it appears to change from increasing to decreasing in some way. I'm not sure how, but we have to find out by testing points. Oh, and I did it on the wrong line. My bad. So the points were 3/2 and -2. So I should check, let's try f prime of -3. And I'm plugging that into the derivative to see if it's increasing or decreasing. So -3 squared is 9, times 2 is 18. Then, let's see, 18 minus 3 minus 6. I think that's still going to be positive. 18 minus 3 is 15, minus another 6 is 9, which is positive. So that tells me it's increasing over here. So next I'll try plugging in a point in between -2 and 1/2, 1 1/2, my bad. And that would be, a good point would be 0. It's an easy one to do the math on. So if I plug that in, I get a 0 and a 0 and then a -6. So it equals -6, which that one is negative, tells me it's decreasing. And then here I could probably guess that it's going to be positive because we're working with a parabola, but just in case you can't, let's do f prime of 2 here. So 2 squared is 4, times 2 is 8, plus another 4 is 12, minus 6 is a positive 6. So it's increasing there. Now, concavity, there was just one possible inflection point. So I just need to test two things. So I'll pick something to the right of my possible inflection point, like 0. So this time I'm doing the second derivative of 0. And if I plug in 0, I just get 1, and I'm using the second derivative equation here. So that would be a 1. And actually, I'm noticing that actually the letter that I'm supposed to use for this function is actually r. So I'll put that. And I should have used r over here on the right, but that's okay. I think you know what I'm talking about. If not, ask a question and I'll clarify. So next I'll try something that's to the left of my discussion, left of my inflection point, possible inflection point. So I'll try -1. So if I plug in -1, I get -4 plus 1, or -3. So I have that it's positive to the right of the possible inflection point, and negative to the left. So that tells me it for sure is an inflection point because it changed concavity at that point. Okay, so now going to write everything down. I know it's increasing from negative infinity to -2, and also from 1.5 to infinity. It's decreasing everywhere else, which is -2 to +1.5. And then it's concave up from -1/4 to infinity. And concave down from -infinity to -1/4. And we already discovered that there's a relative min and a relative max. So yes. And now the question is there an absolute maximum and an absolute minimum? So to answer this question, I want to try drawing a picture to kind of see what we can guess. So I know it's increasing from -infinity to -2, and then from 1 to 1/2. And then I also know that it's decreasing in between, so maybe it'll look something more like that. Okay, and it was increasing the whole time down here and increasing the whole time over here. So if I had to guess, I would say there's no max because it's continually increasing over here. And absolute minimum, I would say no as well. And then and that's not enough, right? Because it's possible that it's increasing like that. That's a possibility. Like it's still increasing, but there's like a, maybe it's like increasing to a point. But what I do know is that if there was an absolute minimum or an absolute maximum, it would either happen at an end point or at a critical point. There are no end points, and I already checked the critical points, so I'm pretty sure no. So I'm going to say no. And then you're welcome to graph it and check me, see if I'm right. This is a big, long problem, so feel free to ask questions on the discussion board.